Hi and welcome. This time around I've got an interesting project. I bought this used on, well, it's new on eBay. It was new open box and they sold it as having some minor corrosion, which it does have, but it's really minor. That's not a problem at all. When you dust this guy off, this is a magnetic chuck, a fine magnetic chuck. And when you dust it off, you'll clean up all this, this minor, very minor rust. I was really excited because I got it for 200 bucks plus another 100 bucks shipping and tax. And look who makes it. And it was sold as brand new open box working. Well, you can see that this is at a funny angle right off the bat. That is an ominous sign. And when I got it, I tried to rotate this and it doesn't really want to go. And you can see it's kind of going at a weird angle. Also, when it's off, there is a slight magnetic field. When it's on, there's no magnetic field. So great find, great deal. I told them I wanted to send it back, but they didn't want to pay 100 bucks to shipping to get it back. So they just said, keep it and give me my money back. So I'm going to try and fix it. Now I know that Mr. Bailey over at, I think it's Mr. Bailey, I can't remember his name right off the top of my head. He was saying that these are pretty dangerous to work on because the magnet pack in the back is so strong that if you get your fingers in there or something, it'll really hurt you. So I'm going to be careful. I'm going to try and fix it because right now this thing is worthless as is. It's a 50 or 60 pound hunk of steel and brass and copper that's not doing me a single bit of good. So we're going to take this apart and see if we can fix it. I'm keeping my fingers crossed. And if I can fix it, I'll send him a little bit of the money back because then I will have gotten a working chuck, well, a fixable chuck. So let's start by taking off the fences here, which unlike my inexpensive Asian copy, these are made out of cast iron or steel. I think cast iron. My Asian copy one, they are made out of aluminum and nowhere near as nice, especially when you want to dust them off, because aluminum is a lot harder to surface grind than steel is. Removing the second fence. Got to say the quality, you can tell the difference right off the bat between this one and my knockoff one. The fence material is a lot thicker, even though the other one's aluminum. They could have made it a lot thicker, but they didn't. And the fit and finish, this thing is ground on all sides and very nicely at that. You can see it's cast iron and they even ground it in a little bit. Here's the bottom that was ground in the factory. And you can see a little more of that corrosion they were warning about. It was beautifully ground, so now I'm making it a little bit duller. But the rust that it does have is not going to hurt anything. It's going to stain it a little bit. It's just some gray Scotch-Brite, and you can see it comes right off. But let's ignore that for now because we got bigger fish to fry. Because if the magnet pack broke in shipping, then this thing's kind of done for. You probably could send it back to Suburban Tools to be replaced, but I shudder to think at how much it would cost. This chuck sells new for about $2,000, and I'm sure the magnet pack is no small part of that. It's got some threaded spots in here, which makes me wonder if they're sort of like assembly threaded portions in this guy, because I don't know what else they'd be for. They're kind of interesting. Some of these guys, the bottom is aluminum. I had a Brown and Sharp that was an aluminum bottom one, so the magnetic pack in the bottom wouldn't affect it. This one's cast iron or steel. Yeah, I wonder if you take these same screws and you thread them back in here to push the bottom up. I wonder if that's what this is for. And we'll see if it comes off on its own or whether you need to jack it off. I noticed on a couple of these, the threads were kind of jacked up. They're kind of flattened over. That's interesting by itself. Makes me wonder if this thing wasn't quite as new as they said, although I don't see much in the way of wear on it. So that's interesting. Maybe used a torque driver to put that in and over tightened it. That seems odd because Suburban Tool is known for their quality. So all of the screws are out. I don't see any pins. Some of the other ones I've seen have been pinned together. Okay. Oh, okay. It's already loose. This whole piece here is a ceramic magnet pack. Wow. So you can tell that this is no longer engaging with anything. Now the question would be, how would you get that ceramic magnet pack out of there? I think you'd want to move this slightly from side to side to engage or disengage, or perhaps lift it. Boy, it is in there. There is some plastic on the bottom. Oh, there's a steel plate so the magnetic field doesn't come out the back. That makes sense. So the ceramic magnets, steel plate to redirect the field back up to the upper plates. You want all of it there anyways. Had some sort of gasketing material going around here. And it looks like you can unscrew the side plates on this guy, which is interesting. I wouldn't have guessed that. That would explain how you can get the magnet pack in and out. All right, so I'm going to take these screws off here and see if these side plates will come off, give me some access where I can actually see what's wrong with it. Because I'm still not quite sure how their mechanism was designed to work. All right. There's some metal shims along the side, I'm assuming to prevent the magnet from rubbing up against the side of this guy. Here we go. I'm not sure how this mechanism goes in or out. Cleaned up some of the old grease, popped this guy off here. This is non-magnetic material, so I'm guessing it's some form of stainless steel, which kind of looks like. But the magnet pack seems like it's rusted, completely solid in this corner. And just based on the gasketing they did, not a great job. Looks like some Teflon tape on the bottom. And I don't know if this is a good idea or not, because once this magnet pack moves, I might be screwed. But it's frozen in place, so that's why it won't slide. So I'm going to try and break it loose and then try and reassemble it, and see if I can get this thing to work. I have a feeling it probably damaged the Teflon tape underneath. It's supposed to space it ever so slightly away from the top steel plate. Well, it's a combination of probably steel or cast iron plates with copper in between, and they're all welded together or brazed together in a brazing oven and then ground flat, or in this case looks like whatchamacallit, Blanchard ground. That's what it looks like, because the squirrel marks are really wide, so maybe they have a Blanchard ground. So I'm going to try and knock this guy free and get it to move a little, and once the rust is free, maybe we can get this thing working again. I don't know, this magnet pack is dangerous like they said. If you got your finger in here, you'd probably lose it. Well, check this out. I didn't think this was going to happen, but I got a couple screws. I got it all lined up again. I broke the rust on it, and now look at the magnet. It's moving. I don't know if it's moving the right way, but it's moving. There's the rusty shim. That one did not go back. It was replaced. Oh yeah, that's working now. Yep. Yep, working now. So I guess we did fix it. I am genuinely pleased and surprised. Clean all the excess grease off that's squeezed out. I really would have loved to get under that pack and put some grease there, but there was no way of getting that guy off. Now the question is, do I want to replace my existing one, or do I want to do something else with this one? Because this one really was kind of in a bad way inside. The rusty, the magnet pack, which is similar to this with steel plates but ceramic magnets in between the steel plates, backed with a steel plate and steel plates on all the sides. The ceramic magnets are either set up to be in line with the steel, or shifted off half so that they're in between, so that they're not making magnetic conduction anymore, so you don't get a continuous loop of field. Think of it as getting a magnetic circuit completed. So another little upgrade is to my tailstock DRO. Now I think this is a fantastic device. I've been using it for years. My only complaint about it is that if you move the tailstock too quickly when you're drilling, you notice how a couple seconds later the final measurement catches up. I've overshot my mark before when I didn't remember to compensate for the fact that even a moderate speed, it doesn't catch up. You notice that was a couple thousandths after the fact? It's kind of slow to read. So my solution was to find an upgraded version of this, or actually the original version of this. And when I went to put this in, I couldn't actually find this for a reasonable price. But I showed in one of my other videos that I got this Miscellany Absolute, and I suspect it will be much, much better. So fortunately, when they clone things like the Miscellany, guess what? The holes pattern is identical. I printed out a scale version of the drawing, set Miscellany on it, and lo and behold, it actually fits. The screws line up perfectly. I'm hoping everything else does, like the plastic extrusions down here. We will find out. So let me unscrew this other one and see how it fits. I also compared the dimensions of this, the shaft itself, and they are also extremely similar. So this guy's just held in by friction. It's designed so that if I ever go past the mark, it's not going to damage it. So this is split. This design is split. And so it actually pops out pretty easily. There's the two pieces. And then it's just two screws on the back here, which I will get off camera, and I'll bring you right back. Well, am I lucky? Do I feel lucky? The old one had two sets of screw holes. I wonder if that's to be compatible with more than one system. So let's see if I can match this guy up next. Got to pop these end pieces off, because this end goes in the wedge and this end's free. Now the interesting question, will the new one read quickly? It still has a little bit of lag, but not as much lag as the old one, but it's not perfect either. Interesting. So my inexpensive clone was not a whole lot worse than the Miscellany original. The Miscellany is better. It has about a 1 second lag, and the old one had like a 2 or 3 second lag. But I think we're good. I think I should have built this fixture so it was tilted a little bit. That probably would have been better. I've got you on a good angle to read it, but from where I'm standing, which is how I use it, it's not great. Got to lean back a little bit, so that's not perfect. But we'll leave the upgrade for now because the zero on it works better. The zero on this guy, see, it started to wear out. You have to really push now, so that was what inspired me to try and find a new one. Next up is a project to move the vise off of my bench. It's been mounted on my bench a long time, which is mounted to the wall. I actually didn't tighten it down, but I've never really liked it because this support beam is not attached to the floor, and I could to improve that, but instead I thought I'd mount the vise out here a ways and make it removable. So I'm going to drill some holes into the floor, put some threaded inserts in so I can take parts on and off, and they'll be flush with the floor and not stick out. So the post material is over here, and there are two pieces because this is for the vise, this 1/4 inch steel, and this 1/8 inch stainless steel is for a mailbox post, because my wife thought it would be nice to have a mailbox post in stainless steel. So we are going to do that. The plates for them are down here, and this is the stainless steel with, I believe they're called gussets. They're going to go in the corners, and I've removed some material so I've got room for a weld bead underneath there, but it's going to support by 4x4 post in the middle, and then the mailbox piece on this is for the top. And this thicker material here, this 1/2 inch material, is for the vise itself. This is the vise mounting side, and I screwed up the first time and put the holes in the wrong spot, but I'll use those for mounting other things hanging off this vise support plates, like some hooks to hang some stuff there, so it'll not get wasted. So these are the 4 vise mounting holes, and this is the base plate, and we just need to weld this up, and we'll be good. And I don't have any easy way of showing the welding, unlike some people. I haven't figured out a good way to get in there when I'm welding, especially since I'm not a very good welder at all. So probably don't want to see it anyways. All right, I'll bring you back when I'm done. Alrighty, so we finished the weld up on the vise stand, and there's gussets underneath and gussets at the bottom. 1/2-inch plate on the bottom, 5/16 thick material on the column. And I've drilled and tapped for the vise and had some location holes in case I wanted to add something else. The only problem is that it wobbles. Now, it was never meant to be freestanding, so that's not the problem. It's that when I welded it, it bumped up there was so much heat put into it that it bumped up in the middle both sides. So I'm going to try something weird, or I'm going to consider trying something weird. I mean, right now it's like a 1/16 of an inch, or about 62 thousandths high in this direction, and a little less so in that direction. What I'd like to do is face off that whole side, and I'm actually going to try that. We're going to try and mount this on my mill sideways and use the horizontal attachment to machine this. I don't know if that's even going to work, but we're going to set it up and see if we can get there. First step in my plan involves using a tool I've never used before, but got it for a situation similar to this, and that is the right angle attachment for my mill. And this goes on the drawbar to extend it up, because your quill will need to be down part way. So how would you tighten the nut? And that's with this guy, so it goes on top. And again, I have never used this, and I'm going to have to align this very carefully. Tricky. So I've never put this guy on before, but let me take you on the other side here real quick. This is made in Taiwan, which is a positive sign. So over on this side of the clamp, there's a set screw in the middle. You'll loosen these 2 guys and tighten the set screw, which splits these apart enough to get that in easily. And then when you release the set screw, it just clamps on the quill right off the bat. And I've already tightened the drawbar, but I got to lock it down all the way. And then we're going to try and align this guy, because we got to get it perfectly horizontal. And I don't know how sturdy this is. Oh, and I got to tighten these 2 screws, of course, to make sure that's clamped well. But I'm not really sure how well these things work, so I'm going to find out. I'm going to try like a 1/2-inch end mill just to flatten out the base of that thing a little bit. So this right angle attachment supports an R8 collet as well. And so we have a 1/2-inch one. There's a tiny little drawbar that's associated with that. Yeah, the alignment screw's sticking out too far. I wonder how you adjust that, because the slot that the alignment screw is supposed to go in is catching on the screw itself. And there's 2 screws, not just one. So I wonder if loosening this is the trick, removing that. I really had no intentions of taking this guy apart. I'm hoping that this guy has like a worm gear or something, although it's not offset, so I'm really not quite sure how they're doing it. Okay, I guess that's held on by the drawbar, and that does not give me access to it. I don't want to disassemble the universe. I don't. So you can see right here, there's your gear assembly. I popped this guy open, and I'm kind of glad I did, because they didn't put much grease on these gears. And strangely enough, surprise, surprise, no access to the 2 screws, which is really annoying. So, I don't know if you can see in there or not, but the screws I'm looking at are sticking down right here, and they're right underneath the gear inside there, so I don't know what I'm supposed to do about that, but they're actually in my way. So the gear assembly is held in here by this preload nut. So there was a single screw pushing this nut out, but now loosening this guy is going to let me take the mini quill out. You can see it's split there, causing it to lock the threads. And well, hopefully I can get it out, because I still can't get to the damn screws. I have to get to this thing to get these screws out. I thought about putting a file in there, but I could damage the R8 ground surface, so I really don't want to put a file in there, but I might have to. Anyways, we're going to try and see what we can do. Well, the ultimate solution was one I really wanted to avoid, which was to get a die grinder and reach in there very carefully and grind those down. And they're hardened, believe it or not. I guess it makes sense, but that makes it really hard to grind off the extra material. Well, we got this guy back together again. Oops. So next, we got to align it perpendicular with the ways. So got to get this guy in there. Next up, I'm loading a precision ground piece of carbide into the collet, and we're going to use that to get this guy straight, and we're going to indicate it in. So got to get an indicator. All right, we're within a couple tenths now, over 4 inches or so. Yep, that'll do. So now I can lock down the 2 bolts on the back here. All right, so we're locked up and we're set up. So now we're done with the indicator here, but we're not done with the indicator completely. And if you're wondering, the drawbar on this guy works the same way as the drawbar up top. When you use the brake on the mill, which is right up here, the brake on the mill also stops this from rotating, so it's dual purpose. If you're wondering about this, this is a micro 100 precision ground 6-inch long piece of carbide, and I use it for things like this when I need something that's good for alignment. Next up, I got the alignment of the whole post here squared up, and have an indicator on this guy running along the post, which it's staying within 1/2 thousandth, which is much better than I expected. So next up, we're just going to try and mill the face of this guy, and you won't be able to see it from this vantage point, but I'm hoping I can just flatten that out to within 10 or 20 thousandths at least, because right now it's off by over 1/16 of an inch. So I decided to use a fly cutter, and I don't have full range across this thing, but I did get the high spots in the middle pretty well. I've got to blend this side still. Unfortunately, yeah, I can't make it, so I might have to rotate this 90, re-indicate it in, and then clean this guy up as well. I decided to use a face mill, a fairly small one. It's a 1.5 inch face mill, and I thought that would work out okay. I didn't have a fly cutter. That's something I need to make one of these days. So I think this worked out okay. It was an interesting experience, plus first time I ever used this guy, so a lot to learn there. And anyways, I'm just going to flip this over and I'll bring you back. All right, so here's one of my locations for the vise stand, right next to the bench where the vise used to be. But I'll make it so it's easy to unbolt from the floor. And to find my center locations for the holes, I use this guy and just mark the center. And I'm going to start with a small drill and work my way up to 1/2 inch. I'm going to start using these 1/2 inch inserts here. And I don't honestly think these are going to be strong enough. They're good for like 500 pounds pull-out strength, something like that. But the problem is that with a vise, when you're banging on it, impact might weaken this. So what I'll end up doing is, if this doesn't work, I will remove these and I will put in some epoxy based studs, and hopefully that'll work better. We're going to try these. Maybe they'll be fine, so we'll find out. These need to go 1 5/8 inch into the concrete, and so we're going to drill that next with a hammer drill. Alrighty, so here's the vise in place. Looking good. Column is rock solid. That's just the vise jaw moving because it's not solid, unlike the bench here, which wiggles all over the place. However, even though I pre-drilled, marked my center, pre-drilled with 1/8 inch, you can see how far off that hole is. I don't know exactly how it happened. I think that the hammer drill, the 1/2 inch, when I did the 1/2 inch, it just wandered outside the 1/8 inch pre-hole. So that's really unfortunate because it's off so much that that's never going to fit. But the 3 bolts seem to be pretty damn strong. This thing does not move. So I'm mostly happy. I'm disappointed that I got a hole in my floor I can't use. But there we are. So this is the first location. The second location is going to be somewhere over by the saw, and I haven't figured that one out yet, so I got to put 4 more holes there. I did put epoxy in these holes on the bottom, so I drilled the holes extra deep, put some spacers, and filled the bottom with epoxy on each one till it's squeezed up around the sides, so there is some epoxy protection. Thanks for watching. Hope you find it useful. Hope to see you next time.